Hello, my name is Marco Mota and this is my submission for Lab3. So in Lab3 we have to implement an arithmetic function using subroutines. The only input to the function is the variable 8 that is initialized in register 4 at the beginning of the program to number 5 and maintained thereafter. The X calculation result is stored in R5 and the final answer F is stored in R7. So I already debugged my program and I'm going to start executing. So first I just clear register 4 and now I'm about to move the value of 5 to register 4. I'm clearing register 5, register 6, clearing register 7, clearing register 8 and 9. So in this part of the program, what the program is going to do is going to copy the value into register 5 and it's going to call for the absolute value subroutine, what it's going to do is check if the number is positive or negative. So it's going to call this function, and this function is our subroutine is here. So what it's going to do is going to test the value and check if the number is negative. If it is, it's going to use two complements, and it's going to run this other part of the code and also this other part of the code. The two complements, what it's going to do is it's going to invert the value on R5, then it's going to increment it by 1 or add 1, and then it's going to go back to the same place where I was. So since my value is 5, so the program will just keep going. Then here what it's gonna do is it's gonna start doing the summation of the factorials. Here is going to move the value of R5 to R6. Then it's going to call for the factorial subroutine. And so the factorial subroutine, I wrote it here. So what it's going to do is going to decrement the value of in R5, which is in this case is 5. It's going to decrement it by 1. It's going to test. It's going to test if it's 0, and if it's not, it's going to call this other part of the program, multi-start, and it's going to go here, and it's going to execute it's going to execute this part of the program, which is going to decrement the value of R5 by 1, and then it's going to jump to here, this other part of the program, and it's going to execute this other part of the program. So it's going to continue now. So that's what it did. It called for that subroutine, the factorial subroutine. Now it's going to finish. It's going to finish the calculation by doubling the value and adding to the accumulator, which is in register A. And it's going to repeat the loop with since we have 5, it's going to repeat it with 4, 3, and 2, and 1, and 0. Now it's going to pop the value what is in register 5. It's going to decrement it. The value in R5 is going to test it. It's going to do the summation. So what it did here is went back It went back to the same program because it jumped back to the same part of the program because it's trying to sum all the factorials. So it's gonna do, I think I summed 5, now it's gonna do the same with 4, so and it's gonna do the same thing. I'm gonna go through the same steps. But what I can do is I establish here a breakpoint, so I'm gonna run and the program is going to execute up to this point. So it's here, and we are in this part of the program. So I'm just going to keep going, and I'm gonna add 2 to the register 5 because I noticed that when I performed the program didn't perform the value of register, I mean the 0 factorial, which is 1, and since I'm multiplied by 2, so that's what I'm adding 2 to the register 5. So that so I have my factorial 0 calculated. And in this part of the program is going to start doing the F calculation, that where we have to add 55 divided by 4. So there I'm moving the contents of the register 5 to register 9. Then in here is going to double the value that was in R9, and here is going to move the value of R9 to R7, and it's going to add, now it's going to add the value of it's going to add 55 to the register 7, and to be able to divide by 4 we're going to use this other part of the code. So we're going to shift it twice. That was one time, and that's twice. And this is the end of the program. So as you can see here, the value of register 4 was 5. 5, and register 5 is 3 or 8 in decimal, and register 7, which is the final answer, F, is 167. So also we have other values that I'm going to do it right quick. So for 3C, the value is 6, and I'm going to execute it. Is to show that my program is working correctly and I have the right values. Here. Okay, so I'm going to start executing the program. We already went through this, and I think there is a breakpoint over here. I'm going to keep going just a little bit more. I call the absolute value, and since it was 6, it's a positive, I just keep going. And I'm popping register 5, testing register 5. So it went back. So now I'm going to execute it. It's going to take me to my breakpoint. And from here, I'm going to do the same thing. It's going to add the value of 55 to register 7. And it's going to shift twice here in order to divide it by 4. So when I have when my A variable is the value of 6, right? This is 6. Was in register 4 was 6. The register 7, which is my final value, is 8887 decimal, and register 5 is 1748. right? 1748, which is my value for x, right? Okay, and finally I'm gonna test a negative number, which is I think it's -7. Yes, -7, and I'm going to debug the program. Debug the program, and I'm going to keep going over here. Still need to show my registers. And here I'm going through the program, it's doing the X calculation. It's calling it went. It just called the actual value, so it it gave me a positive number because it called to this subroutine, and the subroutine what they did is that they changed the value to +7. And now it's calling the factorial subroutine. It's decrementing R5, testing R5. And I'm going to I'm going to resume my program. So it took me here to this other part of the program. I already explained all this, and I don't want, okay. Okay, so when my value is -7, my variable, which is stored in register 4 is -7. Um, the value in register 5, which is my x, is 11,828, and the value of register 7, which is my f, is 5927. It's, yes, 5927 in decimal. Okay, guys, so thank you very much.